Chapter 3.5, Limits at Infinity Day 2, Left and Right Infinite Limits. Today we're going to look at some functions that as we approach infinity with the x, the left and right infinities, negative and positive infinities, may sometimes do different things. Yesterday our limits were fine because they were a polynomial divided by a polynomial. For example, this one, last problem from yesterday, 5x cubed plus 1 over 10x cubed minus 3x squared plus 7. If you put a really big number in up the top, whether it's positive or negative, and you put the same really big number in the bottom, positive or negative will end up canceling out. This one, the numerator and denominator had the same degree, so we divided by the lead coefficients and got 0.5. Here is an example of a problem that's slightly different. Okay, notice we have 3x minus 2 over the square root of 2x squared plus 1. This one has a radical equation in the denominator for our rational expression, and that has x approaches infinity. Let's take a look at this graphically first so we can kind of look at what is happening. So here I got my two functions, 3x minus 2, square root of 2x squared plus 1, and I'm dividing them, y1 over y2. If you take a look at the graph, what's happening with these two functions, as we approach our positive infinity, we see we're leveling off this way to the right as our x values get bigger and bigger. And to the left, as we approach negative infinity, we are also leveling off, but we're leveling off to different numbers. And the reason that happens is because we're taking the square root. Our trick, remember, was to divide the lead coefficient, or divide top and bottom by the same 1 over the same x2 whatever power. Well, what is the highest power? On the top, the highest power, aka the degree, is 1, because it's 3x. Bottom, not quite. On the bottom, it's the square root of x squared. So really, it is 1 over x we're going to have to multiply by, top and bottom. However, because it's the square root, what's going to happen? If we're going to positive infinity, not much. That's going to be okay. We're going to need to do a little adjustment. We're going to need to do a little adjustment because of the square root. What we got, as x approaches infinity, we'll have 3x over x minus 2 over x, and then the square root of 2x squared plus 1 all over x. We can't cancel on the bottom yet, but I'm going to rewrite my x as the square root of x squared. I didn't change it. It just looks different because I need it to fit into that radical. And then when I do that, let me simplify the top first. We got 3 minus 2 over x. And when I do the bottom now, and I split that, I can have the square root of 2x squared. And I can put that x squared under the whole thing. 2x squared over x squared. Now that can cancel. Plus 1 over x squared. And we get the limit as x approaches infinity of 3 minus 2 over x. And on the bottom we got 2 plus 1 over x squared. And as you remember from yesterday, these two things will go to 0 and we're left with 3 over the square root of 2. And if you remember that graph, to the right side, 3 over the square root of 2. This should be approaching it right there. Now, if we do the same thing to the right, the x approaches negative infinity. What's going to happen as x approaches negative infinity here, the top 3x over x minus 2 over x, we'll do the square root of x thing right away. Square root of x squared thing right away, sorry. What happened when we squared x? Well, when you square something, it's automatically positive. So the top of our function is approaching negative infinity. But the bottom, because we squared it, what is it approaching? It's approaching positive infinity. So we need to do a little bit of adjustment. Because we squared it and that got rid of the negative sign, we need to put the negative sign back in. So really, how this looks like when we simplify it, the limit as x approaches negative infinity, we'll have 3 minus 2 over x over negative square root of 2 plus 1 over x squared. Now again, these two things cancel because you're dividing by an infinitely large number, approach 0, and we're left with 3 over negative square root of 2. So when you have a radical that is approaching negative infinity, there's going to need to be an adjustment. When you adjust for the radical, by squaring it, you need to adjust the fact that you squared the negative way by putting the negative back in. So let's take a look at this problem right here. Find the limit as x approaches infinity of x over x squared plus 1. Now, we don't need to show it, but we're going to multiply the top and bottom by 1 over x. The bottom, because it's the square root of x squared, we're going to need to do the adjustment. The bottom will be the square root of x squared, we divide by. And as we simplify what it looks like, we got 1, because x over x is 1. And then the square root of 1 plus 1 over x squared. Right here, that approaches 0, so we are left with 1. If we were to approach negative infinity, when we divided by the square root of x squared on the bottom, we'd have to balance off the squaring and approach negative 1. Okay, now on this one, let's embiggen it a bit. Again, the highest power is x to the 1. So we'll multiply top and bottom by x, 1 over x. On the 1 over x, sorry. On the bottom, we're going to have to adjust a little bit because there's a radical there. It'll be 1 over the square root of x squared. And because we're approaching negative infinity, we need to counteract the squaring, which cancels that negative. So x approaches negative infinity. We got negative 3 plus 1 over x. And we got negative square root of 1 plus x over x. Or actually, x over x squared. Doesn't matter. It approaches 0 either way. And we're left with 3. Because these negatives will cancel. And finally, in review, remember, when you are taking the limit as x approaches infinity, there's a couple things you need to do. If you're finding the end behavior of a polynomial rational function, that is, there is no square root, compare the powers of the numerator and the denominator. Remembering that if they're equal, you divide the coefficients. If the numerator is higher, there is no limit. And if the denominator is higher, then it's 0. And when a radical is involved, pay attention to which infinity you're approaching to remember to cancel the squaring. Remember that the squaring may cancel a negative. So first, for a polynomial rational function, look at the powers. If they're equal, divide the coefficients. If the top is higher, it does not exist. And if the bottom is higher, it's 0. Don't think I said that right the first time. If the top is higher, the numerator is higher, it's 0. Excuse me. Excuse me. And if the denominator is higher too, if the numerator higher, it doesn't exist.